Hello everyone, and welcome to the next part of our MT103 to pacs.008 mapping series. In the previous part, if you remember, we discussed MT103 Block 1, which is called the basic header block. In this session, we will focus entirely on Block 2, MT103 Block 2, also known as the application header block. Our objective is to understand what information the block 2 contains, how its input and output formats differ, and what element can or cannot be mapped to ISO 20022 pacs.008 message. On the screen, you can see this sample MT103 block 2 value, and on the right, you can see some possible ISO 20022 business application header elements. So an important point to understand from the beginning is that this is even for block 2, this is mainly a header to header mapping exercise. We are not yet mapping customer payment information such as the debtor, creditor, amount, currency, account numbers, remittance information, so on. Those details are normally present in MT103 block 4 and will be covered in the upcoming sessions. Block 2 is primarily concerned with message routing, message type, receiver identification, network priority, delivery related information. The main ISO 20022 mapping target for block 2 is generally the business application header, which is commonly called the app header or application header. Let us first understand the purpose of block 2, the application header block. So block 2 helps the Swift FIN network determine how MT103 message should be handled and routed. It tells Swift whether the message is being submitted into the network or delivered out of the network. It also identifies the message type, the receiving institution, the delivery priority, and certain network processing instructions. As mentioned earlier, Block 2 does not contain the actual commercial details of the customer payment. For example, Block 2 does not tell who the ordering customer, who the beneficiary is, what amount is being transferred, what currency is being used, what the customer account numbers are. So those details are normally you will find in the Block 4. The table that you are seeing here uh, summarizes the main information contained in Block 2. So the first item is a message direction. This tells us whether we are looking at an input message or an output message. So input message is basically the FIN message submitted by the sending bank into the Swift network for delivery to another bank. And output message is the same FIN message delivered by the Swift network to the receiving bank. The second item is the message type. So as evident, we are talking about MT103. So this is the message type, the MT103 customer credit transfer. The third item relates to the receiver or sender reference. So in an input block, we normally see the direct receiver, whereas in an output block, you will see the original sender. Inside a network generated reference called the MIR, which we will discuss in the upcoming slide. The fourth item is the priority, which tells Swift whether the message should receive normal or urgent delivery treatment. And then finally, we have block 2 contains network times and references. These are useful for your audit, tracking, and operational investigation. Okay, so block 2 can appear in two formats. One is the input format, and the other one is the output format. So this is one of the most important concepts in understanding the FIN application header or application header block. The input format is created and seen or viewed by the institution that submits the message into the FIN, Swift FIN. That is in short, it's a sender. For example, you can see this particular value. This is a input message format, input value, where with by looking at this particular alphabet I, it refers to the input message. This version tells Swift where the message should be sent. Therefore, the address appearing after the message type, it is after 103, that is this particular character, is the address of the direct receiving institution. So this particular character is a address of the receiving institution. The output format, on the other hand, is generated by the Swift when the message is delivered to the receiving institution. An output block begins with a letter O, That basically means it's an output message. It is longer because Swift adds operational information such as the time when the original message was accepted, the message input reference, the output or the delivery date, the output or delivery time, and the message priority. The difference can be understood through a simple analogy. Let me just give you for imagination. So you imagine sending a courier package. The sender's shipping label says where the package is going to. This is very similar to the input block. Now, when the courier delivers the package, the receiving record includes where the package came from, where when it entered the courier network, and when it was delivered. So that is similar to the output block. So this difference matters during migration when you are doing migration from say MT to MX, because the receiver information is found directly in the input format, while the sender information is found in the output format, and that needs to be extracted from the MIR, or message input reference. Therefore, the mapping logic must first identify whether block 2 is an input block or an output block. Now let us understand the difference between a correspondent banking difference between the input and output using a correspondent banking scenarios. Suppose State Bank of India Mumbai branch is sending an MT103 customer payment to Dowsy Bank, and however SBI does not send MT103 directly to Dowsy Bank. The payment message is routed through JP Morgan in New York. The message chain is therefore SBI, SBI, then it will go to Swift network, and then from Swift to JP Morgan, and then JP Morgan will again send it to Swift network, and another Swift will come to the picture here also, and that Swift will basically forward the message to Dowsy Bank. For the current, we will just discuss the lag between the SBI to JPMC for this particular scenario. For the current Swift transmission, SBI is the sender, and JP Morgan says is the direct receiver. The input block 2, could look like this actually. So let us read this value. Okay, so I means your input. I means that SBI is submitting the message on Swift. Then 103 is the message type, MT103. Then this particular character is the um, uh, logical terminal address. Identifies JP Morgan says as a direct receiver of the FIN message, and at the end, N basically indicates the delivery priority. Here N means normal delivery priority. Notice that Dowsy Bank does not appear in this particular block 2, because block 2 identifies a direct FIN receiver for the current message exchange, not necessarily the ultimate beneficiary bank in the complete payment chain. Now, when Swift delivers this message to JP Morgan Chase, Swift generates an output block. Okay, output block 2. The output block starts with letter O. In the output version, the receiver can identify the original sender to the message input reference, or MIR. In this example, MIR contains the SBI's logical terminal address. So this is the logical terminal address for SBI. Therefore, remember the simple rule shown at the bottom. Input block tells us where the message is going next, and output block tells the receiver where the message came from. Also note that output block shown is a receiver's copy of the same FIN transmission. If JP Morgan says subsequently creates another message for Dowsy Bank, that next transmission will have its own input and output headers. Now let us break down an input block to field by field. So you see this particular sample. So I have tried to break it down with spaces between each unique characters. So the first character is I. This basically represents whether it's an input identifier or output identifier. So here the value is I, which means the message is being submitted into Swift FIN network by the sending institution. So this character is only a FIN message direction indicator. It does not mean that the underlying customer payment is a debit or credit transaction. The next three characters are your message type. The value is M103, which identifies the message as an MT103 single customer credit transfer. The next is the receiver address. This big character is a receiver address. This is the Swift FIN logical terminal address of the receiving institution. In the previous example, it's a JP Morgan size. It normally contains 12 characters. A big is commonly represented using either 8 or 11 characters, while a fin logical terminal address includes a additional logical terminal character. So here A is basically the logical terminal address. Therefore, we should not always copy the complete 12 character LT address directly into ISO 20022 big FI element. It may need to be normalized into the appropriate 8 or 11 character big format. Okay, the next character is priority. So N represents your fin delivery. Depending on the fin message and configuration, you may indicate the urgent delivery. So basically, mostly we see N or U. If it's a normal delivery, you will see N. If it's an urgent delivery, you will see U in the block. Then we also have some optional components as well. Those are delivery monitoring and obsolescence period. So the delivery monitoring option tells the fin network whether and how non-delivery should be monitored. And the obsolescence period defines the period after which a message that has not been delivered is treated as overdue or obsolete under the fin network time. So these last two components belong to the network control layer. They are not part of the customer payment instruction itself. Okay, now we will examine how each input block 2 component should be treated when converting or mapping into pacs.008. The first component is the input indicator. Input indicator is represented by I. There is no there is no direct pacs.008 business field for this value. The reason is that I only tells the fin network that empty message is being submitted into the Swift ISO 200 into the Swift network. ISO 20022 does not require the payment message to carry an equivalent character. Therefore, the input indicator is not mapped into the Swift into the pacs.008 syntax or pacs.008 format. The second component is the message time, which is 103 in empty format. This gives us an important transformation rule. We do not copy the value MT103 in pacs, okay, in ISO message. Instead, we identify the corresponding ISO 20022 message definition for an MT103 customer credit transfer. The equivalent ISO message is generally pacs.008 financial institution to financial institution customer credit transfer, and it comes under the application header message message definition identifier element. So the exact version, so PAX message has many versions. So exact version depends upon the market practice or implementation, such as CVP plus, SBPS plus, or a domestic payment scheme. Then the third component is a receiver address. So this identifies the direct fin receiver. It can be used to derive the receiving institutions big and populate the two party in the business application header in ISO 20022 format. So it basically comes under big FI element. The precise F header structure varies by business application header version, but the business idea remains the same. The block 2 receiver derives the F header receiver. So basically here we remove the logical terminal code, and the remaining character basically goes under this particular element in ISO 20022 as a big of the receiving institution. Next comes the priority. So the fin priority may in certain implementation influence and app header priority element. However, this mapping must be treated carefully because fin network priority and ISO payment priority are not automatically identical concepts. And the final two components, delivery monitoring and obsolescence period, are not mapped into pacs.008. They should normally remain in the messaging gateway, Swift interface, transport metadata. I will just mention they should normally remain in the messaging gateway. They remain in the Swift interface. Then transport metadata, then operational monitoring system, etc. Okay, Now, let us now bring block 1 and block 2 together to understand how ISO 20022 business application header may be constructed. So we have the block fin headers here. We have block 1 that identifies the sending institution or sender bank. In this example, the sender bank is SBI, and block 2 basically identifies the direct receiving institution. In this example, in our previous example, JP Morgan says is the direct receiving institution. Then here on the right hand side, you will see this ISO 20022 format, XML format. So here this from basically this from basically comes from the block 1. This 2 basically comes from the block 2, and then this message identifier basically comes from the message type here in block 2, and this priority basically comes from the block 2 based upon the condition. And since delivery monitoring and obsolescence period are not mapped to ISO 20022 format, we don't see them in this XML structure. So I have just kept two different versions of the XML format. So you can see this is a normal, this payment message is of normal delivery state, and this is something which require high delivery treatment. Now let us move to the output format of block 2. So an output block may look like this. You can see this long message. So this output block is generated by the Swift when the message is delivered to the receiving institution. The first character is O. So this means the Swift is delivering the message out of the FIN network to the receiver. It's a O. The next three characters is again the message type 103, which is again to identify the message as an MT103. The next field is input time. In this example, it's 11:30. So this represents the time at which Swift accepted the original FIN input message. This is normally expressed in hours and minutes according to the FIN format. The next major component is the message input reference, or in short MIR. So MIR basically identifies the original FIN submission. It contains the original input date, it contains the sender logical address, it contains the FIN session number, it contains the FIN sequence number as well. So after the MIR, the original output block contains the output date and output time. These two tell the receiver when the Swift delivered the message. Finally, the output block contains the delivery priority, such as N for normal, U for urgent. Notice how different this is from the input block. The input block explicitly identifies the destination, and the output block concentrates on the message origin, submission reference, and delivery information. Now, before we go into the mapping part, let's look at the MIR first. Let's try to understand what MIR is. So MIR is one of the MIR, also called message input reference. So MIR is one of the most important components of the output block 2. And MIR, as I said, it stands for message input reference. You can see this sample MIR value, and let's break it down. So the first six digits of this MIR represents the FIN input date. It's a FIN input date, and this may be read as a year, month, and day. So it's like year, month, YYMMDD according to the FIN date format. Then the next portion is the sender's logical address. So this is the sender's logical address. This identifies the institution and the logical terminal. You can see this A as a logical terminal here. Logical terminal that originally submitted the message into FIN. The next four digits represent the session number, and it's a part of technical communication between the institution's Swift interface and the Swift network. The final six digits are the sequence number, and this identifies the messages position within that FIN session. Together, the date, the LT address, the session number, and sequence number make the MIR unique for the original FIN submission. MIR is extremely useful for message investigation. This is mostly used for message investigation. Then the FIN audit trails, then duplicate analysis, It is also useful for reconciliation, also useful for operational support. It is also useful for tracing the original sender and linking input and output copies of a message. However, we must not automatically, treat the MIR as an ISO 20022 business reference. Okay, now let us examine how the output block 2 components should be treated in an ISO 20022 conversion. The first component is the output indicator O. There is no direct pacs.008 field for this values like we have seen for input I. It simply means the Swift is delivering the FIN message to a receiving institution. Therefore, it should normally remain in the transport metadata. The next component is the message type. Um, as with the input block, we do not copy 103 directly into ISO header. Instead, we translate the message definition to the equivalent message, which is pacs.008 with a version number. Then the third is input time. This does not normally have a different pacs.008 equivalent. There is no mapping for input time. It may be retained as audit or migration metadata. Then we have MIR det. This is also a FIN reference data, and it should not automatically be mapped into payment date or ISO creation timestamp. There is no mapping for pacs.008. And then we have MIR sender logical terminal address. This is particularly useful because the output block is viewed by the receiver. The MIR sender identifies the institution that originally submitted the message into Swift. This value may help derive the app header and within the big element. However, remember that 12 character logical terminal address must be converted appropriately into the big by removing this logical terminal code. Okay, then we have the session number, sequence number. These are technical FIN references. They are generally not mapped to the pacs.008 business elements. Then we have output date and time. Output date and time. So when the FIN network delivered the message, they may be stored in the technical audit trail, but they should not automatically become a part of ISO 2022 PACS message format. And finally, we have the priority, the output priority. The output priority may potentially influence an app header priority, but only if the applicable ISO implementation defines a valid mapping. So only a small portion of the output block 2 contributes directly to the app header. Most of it remains in the network and audit information layer. So only this MIR sender, message type, and on the conditional basis, the priority. So these three basically contribute to the business application header element of ISO 20022. Okay, now this screen, on the screen you can see this brings the complete mapping logic together. The original MT103 source, the block 1 and block 2. In simple language, the sender is SBI, the message is in 103, MT103, the direct receiver is JP Morgan Chase, the FIN delivery priority is normal. From this information, a possible ISO 20022 business application header can be constructed in this format. We have already discussed in the one of the previous slides. So you can see the sender information goes into this from element. The receiver information goes into the to element. There is no mapping for business message identifier. Then the message type goes gets transformed into the equivalent ISO 20022 message, and this is captured in the message definition identifier. Then there is no mapping available for business service and creation that time. Then there is a priority element as well, where we basically capture the value for the delivery treatment. Okay, and with this, this basically brings us to the end of MT103 Block 2 mapping. In the next part of this series, we will examine MT103 Block 3, which is also known as user header block. We will discuss important fields such as reference information, banking priority, and UETR, and see where they fit into the ISO 20022 pacs.008 message format. Thank you for watching. Please subscribe to my channel for the remaining videos in the MT103 to pacs.008 mapping series. Thank you. Bye.